Assalamualaikum and hi everyone, specifically Dr. Naraini. We are Group 20th and today we'll be presenting on fuel cells in space. So, very quickly, let me introduce our members. We have SOFIA, SHARIFAH, UWAIS, SUTEJ, RAYYAN, GONG HAOTIAN, ZHAO, and myself, Natasha. So, to start off, what are fuel cells? Well, they basically convert chemical energy into electricity, and they only produce water and heat, which makes them fairly clean and efficient. Second, why does this matter in chemistry? Fuel cells are real-life examples of electrochemistry. They are powered by redox reactions, which links directly to what we study. Third, why are they relevant today? Well, it's because hydrogen energy and clean technologies are growing fast, so fuel cells are a big part of that shift. Finally, our focus today is fuel cells in space. So the story is, NASA uses them to power spacecraft systems, support life support, and even make water for astronauts. Also, did you know that during the Apollo missions, NASA used hydrogen fuel cells to generate electricity and even provide drinking water for the crew? And so, with that interesting information, shouldn't we dive deeper into why fuel cells are used in space? So, I'll pass it on to Sophia, who will be talking about the fundamentals and reliability of fuel cells in space.
I'm AQILA Sufyan and I will be explaining about fundamentals and reliability. Fundamentals of fuel cells in space. Firstly, fuel cells are arranged in stacks to generate high power output. Secondly, cryogenic tanks are used to store hydrogen and oxygen as supercooled liquids. As you can see here, this is an oxygen tank where the liquid is flown into the heater and it will flow into the fuel cell to the cathode. Meanwhile, the hydrogen gas will flow into the anode. Thirdly, H2O tank. It is used to store water produced for other uses. The fuel cell will produce water as a product, and the water is stored for other uses such as consumption or other daily needs. Next, battery or capacitor. It is used to store excess electrical energy, and provide it when it is needed. Moving on, electrical motor. It is used to receive electrical energy and to convert it into mechanical work. And lastly, the coolant system, which is this three: the coolant outlet, coolant pump, and the coolant inlet. It is used to absorb waste heat release. The fuel cell will generate excess heat, and the waste heat produced is absorbed by the coolant system. Moving on to the reliability of fuel cells in space. Firstly, fuel cells are more stable than nuclear fuel, and it also does not need charging unlike secondary cells. Secondly, fuel cells are low in weight and volume compared to other electrical energy generator, and it is ideal for space travel. Lastly, fuel cells are designed with multiple independent fuel cell stacks. If one fails, it can be isolated and the others can still continue to function.
Hello, this is SHARIFAH IZZATUL NAJWA, and I'll be presenting about high energy durability and efficiency of fuel cell in space. The first point would be fuel cells act as a long-lasting power sources. Unlike batteries that eventually run out, fuel cells can operate continuously as long as hydrogen and oxygen are supplied. This is very important during long missions where astronauts need a stable and reliable supply of batteries. Second point, which is fuel cells have high energy density, which means that they provide more power per unit weight compared to the conventional batteries. In space, which we all know, every kilogram, every weight matters. So having a lightweight energy system that can produce a large amount of power is a very huge advantage for the astronauts. The third point, which is fuel cells, shows a very reliable performance in extreme environments. space which has no atmosphere, extreme temperature changes, and microgravity. Fuel cells can handle all of these conditions while still performing consistently. Their solid structures and electrochemical process make them more dependable than combustion-based systems in space. One, which is the last one, is the fuel cells produce water as a natural byproduct. This is very, very useful for the astronaut because they can use the water. They can reuse the water for drinking and other life support functions. This reduces the needs to carry large amount of water from Earth, saving both weight and cost.
Fuel cell have two major space travel challenges, which is generate electricity and generate water. Fuel cell help to produce electricity by converting chemical energy to electrical energy. This include electrochemical redox reaction in fuel cell. In this reaction, electron flow through external circuit. It generate electricity. Electricity is important in space travel because it used to power spacecraft system, communication equipment, life support system, and navigation system. Then, fuel cell also help for water production. The product of reaction is pure H2O. In NASA Apollo mission, water was used for drinking water, cooling and humidity control, and also it control the temperature of fuel cell. Why is it important for fuel cell to produce water? Why we don't bring water from Earth, right? It because water difficult and expensive to transport into space. Then we solve the problem by produce our own water in spaceship. That's all.
Next is NASA's use of fuel cell. I'm SUTEJ. I'll be talking about Apollo's fuel cell and global development.
Hi, so on my part, I'll be talking about the Apollo spacecraft fuel cell. The Apollo spacecraft needed electricity and water. NASA used fuel cell instead of heavy batteries or big solar panels. Fuel cell combined with hydrogen and oxygen to make electricity for the spacecraft, and also drinking water for astronauts to drink and heat. One device did all, saving weight and also space. They were built by Brett and Whitney, which is a US-based company. Why it's so important? Because batteries were too heavy, solar panels were too big, but fuel cells give steady power and also water. An example, on Apollo 13, an oxygen tank exploded, which stopped fuel cell and also causes the spacecraft to lose power.
So hey guys, for my part I will be talking about fuel cells in space shuttles and why they are so important for space missions. So, for your guys' information, fuel cells play a major role in powering spacecraft because they can generate electricity and water at the same time. This is extremely useful in space where every kilogram of weight matters. Fuel cells are lightweight, compact and produce more power per unit weight compared to batteries, making them ideal for long-distance missions. And then, in space shuttles, hydrogen and oxygen are stored in cryogenic tanks, and the fuel cells are arranged in stacks to produce high power. One big advantage is reliability. Even if one stack fails, the other can keep working, which improves astronaut safety. Other than that, electricity, the chemical reaction inside fuel cells also create pure water, which astronauts can drink or use for cooling and humidify control. This reduces the need to carry large amounts of water from Earth. Fuel cells have been used in real missions like the Apollo missions, where NASA relied on them for life support and spacecraft operation. For example, during Apollo 13, where an oxygen tank exploded, the fuel cells stopped working, showing how critical they were to the mission. As you guys can see, there is fun fact, every mission of space shuttles program use fuel cells for onboard power. Overall, fuel cells allow space shuttles to operate continuously, handle extreme space conditions and support long-term exploration. That's all. That's all from me. Thank you.
Global development on NASA's fuel cell. Japan leads in fuel cell cars and home systems like Toyota Mirai E&E Farm, building on ideas first used in NASA's space fuel cells. Germany's company, including BMW, Bosch, advanced PEM fuel cells based on early space design. The US Meanwhile, the US, ESA and DLR develop regenerative fuel cells for satellites and lunar bases, while industry uses them for clean energy. South Korea focuses on hydrogen system and fuel cell buses, following progress shaped by aerospace research.
Next are the challenge and future innovations of sales. I'm Gong Haotian, and I will be talking about the challenges for sales in space. Major challenges we face in developing using the space-based fuel system, especially hydrogen. First, refueling in space is extremely limited. Both hydrogen and oxygen supplies must be transferred from Earth, and which adds a significant logistical complexity. Even when hydrogen can be extracted in space, the process often still depends on fuel-based amounts, making current solutions neither fully sustainable nor efficient. Second, the mass and the volume of the fuel system are major concerns. Large storage tracks at the sustainable launch weight, increasing mission cost dimensionally. And speaking of cost, producing and storing hydrogen remains expensive, especially under the extreme conditions of space. Storage tanks must be withstand vacuum environment and large temperature swing, which requires advanced materials and engineering. Another key challenge is public awareness in infrastructure. On Earth, hydrogen technologies already face gaps in refueling infrastructure, and these gaps become far more significant behind our plans. Finally, we must consider the thermal and water management in molecular gravity. Controlling heat and managing the water byproducts become difficult. Adding new layers of engineering complexity that don't exist on Earth. In short, while hydrogen and the other space force hold a great promise, we still face the major obstacles from the high cost and heavy system to shortage difficulties and limited the full refueling options. Overcoming these challenges will require innovation, invest, global cooperation as we move towards sustainable future in space exploration.
Hi everyone, I'm going to talk about the innovations of fuel cells in future space exploration. The first innovation is the use of local resources in space instead of transporting everything from Earth. Sending supplies from Earth is really expensive, so if astronauts can get basic materials like water and the oxygen from the lunar surface, the payload mass can be greatly reduced. The second innovation is the development of a regenerative system. For example, the Honda company is combining high differential pressure water electrolysis system with a fuel cell system. During the daytime on the moon, solar power is used to supply water into oxygen and the hydrogen, which are stored. And at night, the fuel cells use these gases to produce electricity. So this provides a stable power supply for astronauts living areas. The last innovation is improving the efficiency and the durability of fuel cells because platinum group metals are expensive, so it is possible to innovate electrocatalysts that do not contain platinum group metals. And additionally, carbon-based catalyst support can break down under harsh conditions, so developing corrosion resistance, high conductivity, and cheap nanoceramics is more crucial, such as titanium diborate and silicon carbide. And alright, overall, the innovation will make fuel cells technology more efficient and sustainable for space exploration. That's all. Thank you for your listening.
So, to wrap everything up, fuel cells basically provide really clean and reliable power sources in space. They're also strongly linked to electrochemistry, which makes them ideal for spacecraft. NASA also uses fuel cells for the Apollo missions, to space shuttlers, and they'll even continue for future innovations like closed-loop energy cycle. In addition, they produce electricity, they also produce water, and even support life in space. However, of course, there are still challenges like hydrogen storage, high cost, and even the durability in space. But new innovations like better catalysts and regenerative systems are making fuel cells more efficient and sustainable. Overall, fuel cells will continue powering missions beyond Earth, and they'll remain a key part of space exploration. Thank you, and that ends our Group 20th presentation on fuel cells in space.